Hello and welcome to the first video in the MechLab System Editor tutorial series. My name is Tom. I'm the lead developer at Automated Design, and this series of videos is going to take you through using the MechLab System Editor. The MechLab System Editor is what defines your project. In this video, we're not going to drill too much into the details. We're going to go through the tree view, describe the groups, what's available, what gets done there, so that when we're talking about different items in future videos, as we drill down into the more specifics, when I talk about another part of the program, you'll at least have some basis of understanding of where I'm talking, what I'm talking about, how these things kind of play together. So let's just get to it. Typical menus here. Each MechLab project is a collection of files that's kind of self-contained. So you can make a new project, you can open a project, you can save your current one, you can import an existing project. Let's say you have a project that you like, but you need to modify, so there's a slight change to a test or something, or you just have a good template that has most of the work done. You want to kind of get a good jump on it. You can import that existing project. Most of the time, if you're doing importing, you're going to import and export project archives, which basically takes your entire project, compresses it down into one single file, allows you to pass that around or archive it on your server or use it as a template, and you can import directly from that template. System. MechLab is a collection of multiple programs, and most of them end up talking to the Mech server, which is a service that runs in the background. Also, MechLab is designed to integrate with regular standard vanilla Python, no special versions here. You get to install and use the version of Python 3 that is working for you or is already on your system. There's just some configuration of MechLab and some support files that needs to happen, and you can just do that real quick by clicking that button there. What we're really going to talk about are these groups here. MechLab is designed in a tree. So devices. Devices are your devices in the real world. MechLab does not just run inside your machine. It talks to other devices, other machines, and it allows you to define these in a flexible manner so that one installation of MechLab can talk to many different devices, and you can set them up differently. Not every test you run has to use the exact same hardware in the exact same way. That gives you flexibility of the system. Adding in devices is easy. You simply come here, add a node to the tree, and the available plugins are listed there for you. So if one not in use in this particular project is talking to a Modbus device, then you just start setting up your particular controller. In National Instruments, everything has to be put under a task. So your next node of a tree is a task. And under there, we can start adding in our analog inputs, and we can list the address for that input. Here's an encoder input. It's all there. We'll go through this in later videos. This is the protocol, ADS talking to backoff PLC, and this is the definition of a particular PLC at this address. And then we start drilling down into the particular items. One thing to notice here is scaling. So scaling is built into the MechLab tags. You don't have to scale in your interface. You can scale right there in the tag. Well, here's a good example here. We put in a pre-scaled value, an engineering value here, and a scalar and an offset are calculated. DAC stands for data acquisition. Once the data comes in from the devices, we want to put it into software buffer groups. In this particular case, we have a buffer group and recording from the counter 0, which is a channel defined over here. You'll notice this tag name here, and we have the matching tag name here. Every item in the tree gets a tag name that allows you to identify it and can reference it from anywhere else in the project. We also have triggers. This is a rising edge trigger that we can define tie it back into the buffer group that it's going to trigger, tie that back to a signal. We can define things like dead time. These are in a data acquisition, like a typical data acquisition application when you're using a scope. You're going to want to trigger the scope on an event, and these are some of the triggers available to you. We can also do following the edge, above level, below level, equal to a level, not equal to a level. And you can trigger singly, or you can just keep re-triggering. It depends on your application. When your trigger completes, you generally want to run a method. What is the method? The method is the calculations. On the values and configuration and cycle data measurements, information, and results, these all get passed into the calculation script. So you're defining things here that you would want to configure. And the configuration group is generally values like you're putting in the weight of the bat, some correction factors for a ball or something. These are things your operator is going to type in that the machine cannot discern automatically. Cycle data is data from a cycle, from a test cycle. So in this one, we define the calculations we'll be making. This is helpful not just because this gives us script a place to write, but this defines what gets displayed in the cycle data section of the lab interface. So if you want something displayed in a row, you simply add it here. One of the things to note is cycle data has a few different ways to put data into an item. For instance, ball code is simply going to pull the data from method information ball code because it's helpful in the cycle table to have that data referenced there. So method information ball code, this is getting entered. It's metadata that is being typed into the screen. Instead of having to do anything extra, this is just automatically going to be copied in at the end of a cycle and be placed into the table. Then there's other items like this that will probably be calculated from the script and then displayed in there. And there's certain functions that can happen. For instance, right now we're supporting averaging and sum. Those are the most common. Measurements. This is information that you need to run your calculations. And cycle data and results are outputs. So if we think through this tree again, configuration is an input. That's data that you're going to use when calculating or just want to store somewhere. Information is an input from your operator. It's just metadata for tracking purposes. Cycle data and results are going to be outputs. Those are things that your script's going to run. You're going to make a decision. You're going to output some values. You're going to make some decisions. Processing is kind of a special group. Processing is where you do your Python integration. You also get an editor built in with code coloring to kind of give you an exam, to kind of guide you through. There's some code editing features, and coming soon in a future release, there'll actually be code completion and help for you as you type through. So you can do all your editing right here in the MechLab System Editor. That being said, you can also do it in your favorite external Python editor. The choice is yours. Display is specific to the lab interface. The lab interface follows a rigid structure. It defines places on the screen where you can suggest controls, have different items for this, different items for that, but they generally follow the same template. And so there's a system area, there's a configuration area, there's a footer, there's a header, there's an information tab. And you'll notice we talked about bat code earlier being part of the method. Information gets written to the bat code, and then the bat code was just being displayed in cycle data here. So to do that, you want to put that on the screen. So you could put that in the information section of the screen, and then you tell the system, well, this is what that I want that value to be that we're going to be editing, and you can tell it, what kind of control you want. And depending on where you're placing it, you might actually be able to put it into a table or a complicated layout, and you can define where it is in that layout using row index and column index. You don't even have to allow this to be editable. It can just be for display. You can add in a description that if your mouse is hovering over will display in a tooltip. And instead of just having a nonsensical tag name, you can give it a label, and that gives you a better description. Standard signals and standard links, these are not things that go on the screen. These are certain controls in a MechLab lab interface that are there, like a start button, a stop button, and we know what function we want them to perform, but we don't know exactly what bit in the controller or what item in a National Instruments DAC or in a Modbus communication device or what have you has to happen. So these standard symbols and standard links are items that a generic item on a generic widget on the lab interface will make a signal to, and then that will get used to be triggered or write values, process values inside MechLab itself. It's basically like a router. Things get routed. For instance, here the lab interface has a panic button. It will write standard signal panic. It will write this tag right here. And this will get mapped to do these functions, to get to actually go through and list and declare functions. You can write value, reset value, pulse, all these things, and it will write all these every time. It will perform these methods every time the signal comes in. In that way, by not having a pre-canned reaction, by allowing the action of it to be defined by the user, it's very flexible. Release, control, I'm going to skip through. That's a whole complicated topic. This is where you will do PLC-like functionality. To keep this video short, and because that's a topic in and of itself, that's what that is. It probably won't be a part of this series. We're going to handle that separately. This is the main overview of the system editor. If you feel like you don't understand it, don't worry. We're going to go through each section in detail. There'll be training on devices. There'll be training on specific plugins. We're going to go through data acquisition. We're going to go through the methods in detail. You will understand everything. Thank you very much.